Okay, now we're going to write a two-column proof. Two-column proof is one of the more common types of proofs that you'll run into. Just like the paragraph proof, it has the same basic components and structure. So it has an introduction, a body, and a conclusion. It's different than a paragraph proof in the same way that a paragraph and an outline or a paragraph and a bullet list are different. It's much more brief. It's you don't necessarily have to write complete sentences in a outline, although it helps. So here we're going to construct a two-column proof. So just like before, we're going to start off with our introduction. Now this is the same exact proof, so we're not going to go through, all of this as much. But the introduction is going to be your given information, which could come directly from the written information, or it could also come from the picture. We can take it directly from that as well. And we're going to just number everything. Instead of using bullets, we're going to use numbers. They have to match up. So for everything you say, every statement you make, you need a reason, a corresponding reason that backs it up. You can't just say something and you just assume everybody else knows why. You have to tell everybody why for every little detail. So the first one is angle 1 and angle 3 are vertical angles, and I'm kind of running out of space there, but hopefully you can still see that. So I'll move the 1 over here. So they're vertical angles. And how do we know that? Well, we know that because they tell us right here at the top, and that's going to be called given. They gave it to us. So that's our reason, given. Now we're going to start with our body. Our body is going to keep going down, start here and go down until we complete everything we need to prove our case. So just like before, we look at angle 1 and angle 2, and also angle 2 and angle 3, and we know the definition of not supplementary angles, but linear pair, and that's what these form. So remember, two angles that share a side and form a line at the base, that's a linear pair. So angle 1 and angle 2, and angle 2 and angle 3 form linear pairs. You could put these on separate lines if you want. I'm going to put them together in this case. The reason is exactly the same for both, so I'm being a little lazy, I suppose. But we know what a linear pair is, and remember, what is a definition? So what is a definition? Is what we know about something is a theorem or postulate or something like that. So what it is, definition, and so that's what we know. Definition of linear pair. Now, we also know that the measure angle 1 plus the measure angle 2 equals 180, and we know it's true for both of them. We know that the measure angle 2 plus the measure angle 3 equals 180 as well. We know that by the linear pair theorem. So just like before, I could write this as two different rows. I'm just going to leave it as one, and because the reason for both of them is exactly the same. It's the linear pair, which I'm going to abbreviate linear pair theorem. Now remember, just like before, they both have this in common, so that measure angle 1 is equal to 180, and this measure angle 1 plus measure angle 2 is equal to 180, and measure angle 2 plus measure angle 3 is also equal to 180. So we're going to say that since these two are equal to 180, that's the same in both cases, we can replace it. We can put that in here and get rid of the 180. So measure angle 1 plus the measure angle 2 equals the measure angle 2 plus the measure angle 3. And all we did was we substituted. So we got rid of that one and we put in this whole expression on the side. So that's the substitution property of equality. So now, remember we have these two items, measure angle 2, which shows up on both sides of the equal sign. So we can subtract it from both sides, and we end up with measure angle 1 equal to the measure angle 3, and we need a reason for that as well. So, and it needs to be the same. We need to be able to see very easily what it matches up with. What did we do? We subtracted. So that's our subtraction property of equality. And then finally, we're not done until we've proven up here what we need to prove. So that's our proof statement up here. Okay, that's going to have to go right here as well. So the given always, I mean, there are times where I suppose you could do it. You wouldn't have to have the given first, but we almost always put the given statement first, and the proof statement goes last. Angle 1 congruent to angle 3. Now, based on everything we've done, the step just before the proof statement was saying that measure angle 1 is the same as measure angle 3. Well, that's the definition of congruence. So when two angles are congruent, I mean, when the measures of two angles are equal to each other, that means they're congruent. So I'm going to put a definition, and I'll abbreviate it, of angle congruence. And that's the end of the proof.